Hello. Today I'm going to talk about some techniques, some data manipulations. How to do how to deal with some data frames, arrays, metrics, those kind of things. First, you need NumPy and pandas, and I create a random, matrix, data frame. So this is a matrix, and I just convert those metrics to data frame. It's easier to work with. Make sure the size 5, like 5, which means there's 5 rows, 5 columns, right? So after I run this, you can see here this is M1 and this is M2, right? So I got this data frame created. Alright. So after this, I use one tool called M1.m2. Okay, this is one way called, this is what we call matrix multiplication, right? But it's multiplication based on metrics. Alright. Let's run it. So you can see this M1, this M2, and M3, alright? When we pull all this up, you'll find out, I have different numbers down here, and the first number is actually the first. So the first number is the result of first row. Okay, multiply by first column, which means you can see this is first row and this first column. It's actually 3 multiplied by 0, 2 multiplied by 4, 4 multiplied by 2, and 4 multiplied by 2, and 3 multiplied by 4. Okay, so it's 1 by 1, but it's row to column. Okay, so get this number. Alright. Alright, so and this trendy is given by still the same row but multiply the second column. Okay, so that's what it was. So you could check on that. But this is metric multiplication. Alright. So the other multiplication is what we call element-wise or vector-based multiplication. You just simply use this multiply function, use the data frame and the other data frame, and let's run it. Then you can see, so this is the first one, this is the second one, and this is the result. And you can see here, this is what we call element-wise, is because they all relate with each other. Like this one is the 0 0, right? Index 0 0 is actually multiplied by index 0 0 in here, multiplied by here. Okay, just same position, the cell of same position multiply with each other, right? Like this is 2 0, right? Actually 0 2. So it's 4, and this is 4 also. So we get 16. Okay, so it's really cool. We use this a lot. The same concept is the add. If we do add, we'll have, we basically will have the same location, but instead of multiply, we use add. Okay, so 0 add 3 is 3, 2 add 0 is 2, 4 add 4 is 8. So pretty simple and easy, but it's very effective. You will use this a lot later. Okay, so usually we use this is because if we have 2 data frame, right, but they're in the same structure, same size, same number of column and row, you could actually for example, like this one, if it was For example, if this is ID, the column is ID, and here is different variables, and here is ID and different variable also. You can just like add them together or multiply them together, just to get the value of two different variable, you know, be together, what it looks like. Okay. You know, for example, if this is like, let's say the height of you know, like gender, right, and this is like salary, then you could add them together and see, you know, what's the effects of both of them together. Okay, so things like that. The other really important thing is apply. There are two kind of apply, which is you can apply functions to the elements. In the series, in data frame, arrays, matrix, all those. One thing is apply. What apply do is it will put a function in here. We just sum. You can put a function to a row or column. Okay. Let's just apply this. Then you can see here, I actually is the result of, you know, different rows add together. Okay. You can actually tell them you want a column or a row. Okay, but apply map is kind of different. If I run this one, apply map, the same thing to the M4, which is this data frame. It actually return an error. Okay, because apply map will apply the function to every individual cell. So it will apply this function basically to the single cell in here, like 0. Okay, you cannot just sum one elements. Okay, you either sum a list, array, or something others. So this is just one number, so you cannot sum it. So it says you know, it's integer. This object is not iterable. Okay, so it's not like list or array. So so you can, you know, but you can scale it. If you, let's say if we scale it, so they got a scale. Okay, like power 2. Okay, so this was this. The other really important thing is map. What a map you do is kind of similar with apply map, but you can apply to you know, if this is a list, right, you can write down the lists in, you know, after comma. Okay, so this is a function and you put the list down there. Let's say if we print it, see here, you will return, you know, the list with like every single item in the list will have a function in there. Okay, so basically that's what this is about. And filter is kind of different. Is you have function, but that function is kind of like a filter. For example, we have a list, right, and we'll have list, we wanted the square of the item list smaller than 6. So let's just run it and you will see. So just return 1, 2, which means only 1, 2, their square is smaller than 6. So basically that's what I mean. Let's say if I change it to 10, you can see the difference. Okay. Then we have 1, 2, 3, because 3 square is 9, right? It's smaller than 10. So they will keep this for us. Okay. And for lambda is actually really simple. Basically lambda is we see this kind of function a lot in mathematics. Is definition x is independent variable equals x squared. So this is kind of like the functions. So we just, you know, use lambda to replace def and x in independent variable, and then we write down, you know, how we calculate, you know, how we use independent variable to do calculations. Okay. And the g is basically a method of this lambda like functions. Okay, so let's say we print it g2, see we got a 4, which is 4 square. Okay, it's really really simple but really effective a lot of times. Okay, so that's this for today. Thanks.